All right, so we were talking about diurnal motion and annual motion. I think I ended with this slide right here. Let's go to the next slide. Keep in mind, this is all about the celestial sphere, um, and of course, there's the celestial equator, which is just the Earth's equator projected out into space onto the celestial sphere. Um, of course, there's the celestial pole. The celestial North Pole is just the projection of the Earth's pole out into space, and the celestial South Pole is the projection of the Earth's South Pole out into space. One thing about that is that there happens to be a relatively bright star in the northern hemisphere, really close to the celestial North Pole. It actually turns out there's not um, a bright star. So what I mean by a bright star is a star that you can see with the naked eye, so with the unaided eye, and so that star is actually called Polaris. It actually goes by several names, but the North Star sometimes it's called. That's a very important star in the sense that humans have used that star in the northern hemisphere anyway to navigate for a long, long time, for thousands and thousands of years. It actually is prehistory, that prehistoric times that people actually used the North Star. All right, so getting back to this annual motion. All right, so let's say you have, for example, a particular constellation that is, let's say the sun goes down, and there's the sun goes down on a particular evening. I guess this is in the summertime, or almost the summertime, and let's say, for example, you have the constellation Gemini, um, and if you were to wait a month, or just look at a month later when the sun goes down, um, you would notice that the constellation Gemini is actually, it makes it hard to see the constellation Gemini. Um, and what this is, of course, is the Earth moving around the sun, right? Where we move roughly one of these constellations of the zodiac a month, right? So, you can it actually turns out it'll be really hard to see Gemini in July, um, and so right after the sun sets, it's much easier to see Cancer, and Leo and so forth. Uh, all right, and that's just because the sun is in the direction of Gemini now. Before it was in the a month earlier it was in the direction of Taurus. So a month later, right? So in July you could see Cancer, right after the sunset, and then let's say a month later, when in August, Cancer is now below the horizon, and it it would be really hard to see Cancer. Um, and so there's Leo. The sun sets, and you're in Leo, or the sun sets, and the constellation Leo is right on the horizon, and you can make it out. It actually turns out. This is a little bit deceptive. Um, when you look at the constellations, and you get this is how they look, um, when you're looking at the constellation almost directly towards the south. In other words, the constellation is much higher in the sky. When it gets close to the horizon, it's difficult to pick out, except for constellations that have really bright stars. Um, it kind of, how can I describe it? It just makes it difficult to make out the constellation. The shapes that are the constellations are are defined by, basically when you're looking at the constellation kind of um, when it's the highest in the sky, all right, which is not always the situation. Um, all right, so this is the annual motion. This is the kind of thing that we're talking about. Of course, the Earth is going around the sun. So here's the Earth going around the sun, and as the Earth goes around the sun, the sun would be in different constellations. Um, but by the way, notice um, between Scorpio and Sagittarius. So see these two constellations right here. Um, there's actually another. So these are the traditional 12 constellations of the zodiac. You've probably heard of most of these, Leo and Virgo and so forth. But there's actually another constellation, a 13th constellation. By the way, so this line right here, this dotted line, is that's the ecliptic. That's the path of the sun. All right, the path of the sun in the sky, and it passes through certain constellations. Of course, the 12 constellations of the zodiac. Well, there's actually a 13th one that is actually between Scorpio and Sagittarius. It's right about here. It actually extends just a part of it, a small part of this constellation. It's called Ophiuchus, and so Ophiuchus. I forget what Ophiuchus is. It's like the water bearer or something. I don't remember what it's supposed to be. Remember, these are just regions of the sky. That's all they are. For astronomers, that's all that's important about them. All right, so here, let's move on. The path of the sun in the sky is called the ecliptic. I just mentioned that. The ecliptic is the projection of the Earth. It's really the Earth's orbit, but it's also from the Earth's perspective, that's the path of the sun. All right, and of course the ecliptic it's kind of like if you looked at it on the celestial sphere, it goes up and down. Like the topmost part is Gemini, and the lowest part, it looks like your traditional sine wave. So the top part is Gemini, the bottom part is Sagittarius. And a little more about Sagittarius. Sagittarius uh, is actually the direction of the 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 center of the Milky Way, our galaxy. Um, we'll talk a little bit more about that later. All right, so the belt-shaped region of the sky surrounding the ecliptic passes through it's the 12 traditional constellations of the zodiac. There is, of course, a 13th one. Oh, they even put it in here. Very nice. Ophiuchus. There it is right there. Oh, I guess it's the snake charmer. I, I said that wrong earlier. Okay, so I guess Ophiuchus is a snake charmer. Not that matters, right? I want you to all understand that. The I mean, it's just a constellation. Um, all right. Anyhow, it is again. It's between. It's just a small part of it. For the constellations, the traditional 12 constellations, the sun is in these constellations for about a month, roughly a month. The part that passes through Ophiuchus, it only lasts for about a week or so, maybe a little bit more than a week. All right, so the Earth is actually closest to so the Earth gets a little closer to the sun, a little further from the sun, because the path of all the planets is not a perfect circle. It's what's called an ellipse. So it gets a little closer, a little further. We'll have a lot to say about ellipses a little bit later. That has to do with a guy named Kepler. We'll talk about him in the coming chapters, not so much in this chapter. But anyhow, it actually turns out it's usually what is it, about January 4th or so is when the Earth is closest to the sun, and that happens the exact same time every single year. And so that usually confuses people. That why is it not why is that not the first day of summer, for example? You might think because we're closer to the sun, that would cause summertime. So the difference in distance to the sun is only slight, compared to the distance between the Earth and the Sun. It's only a slight difference in distance, and that's not the cause of the seasons, right? The seasons are caused because the Earth is tilted, and that tilt, right? So there's the tilt of the Earth. That tilt doesn't change throughout the year. The Earth orbits the Sun with that exact same tilt. So that means that there's times when the northern hemisphere is tilted towards the Sun, and then 6 months later, the northern hemisphere is tilted away from the sun. That we can actually see that better in the next slide. The Earth's axis is tilted by 23.5 degrees. So 23.5 degrees. That's actually really important. Mars, for example, is tilted by almost the same amount. It's 24 degrees. Venus is hardly is actually that's a totally different story. Venus is flipped upside down, right? The northern pole would be pointed down here. Um, yeah, that's a different story. We'll get to that when we get to Venus. All right, so this is what I'm talking about. With the seasons, all right. So let's say it's December, right? It's in December. You normally think of it's cold. It's cold in the northern hemisphere, right? It's very cold in the northern hemisphere because in December the northern hemisphere is tilted away from the sun. But if you lived in South America or different parts of the world, in South America, South Africa, or Africa, most of Africa, and Australia, for example, December 21st is the first day of the summer, right? That's the exact first day of the summer, right? They don't use a different calendar because you're in Australia or in South Africa. It's the exact same calendar, so it's just summertime for them. For people in the northern hemisphere, which, by the way, of course, is most of the population of the human race. Most of the population lives above the equator in the northern hemisphere. So we normally we think of most humans, unless you live in the southern hemisphere, most humans uh, associate with December with wintertime. All right. So uh, as time goes on, the the um, so here there you get December. 3 months later, you've got March, and so notice at that time, the northern hemisphere and the southern hemisphere are well, they actually line up with what is called the vernal equinox. This is the first day of spring. Right. So in the north, if you go back to the in December, the Earth is tilted away from the sun, and the northern hemisphere is tilted away from the sun, and so people in the northern hemisphere get um, the least amount of sunlight during that time, and in the southern hemisphere you get the most amount of sunlight. In what was 3 months later in March, you get an equal amount of sunlight in the you know that's why they call it the equinoxes, right? There's an equinox. It's called the vernal equinox. That's the spring equinox, and then the autumnal equinox, 6 months later over here for September. But anyhow, let's continue. First day of spring, you have equal amount of day in the northern hemisphere and in the southern hemisphere. Um, and then as time goes on, you get 3 months later, then